Hi guys, so in this section we're going to look at transformations, and if you'll notice in Blackboard I have quite a few handouts associated with this section. I'm going to pull up a couple of those. The first one is listed as common equations and their graphs, and these are functions that you should be familiar with, and you wouldn't even have to go to your calculator to generate a graph of these, that you kind of have like a mental picture. And so if you don't have these already in your head, then you want to start getting more comfortable, and anytime I say linear, you really already should be there. You should know linear line, so straight line. Okay, now of course they don't always, rise, sometimes they fall. Then below that you have your quadratic. Those are always your parabolas. Remember, they can face upward or face downward. Here, the next one down is y equals x cubed. These are all referred to as parent functions, by the way, okay? Absolute value functions, always your v-shaped curve. Over on the right hand side, I give you a picture of your square root function. We saw that in the last unit when we were talking about domain. And then just below that is your reciprocal function. So all of these are common equations and they're graphs that you want to start getting more and more familiar with, that you know them. Like I said, whenever I say quadratic, you immediately have a parabola coming up in your head and saying, okay, I know what she's talking about there. Okay. All right, so now I'm going to draw your attention to the other handout that I have online. I'm not going to spend a whole lot of time on this handout. I think that it's fairly self-explanatory by what I have posted online in terms of this particular handout, but I just wanted to, advise you that, hey, it's still there. And essentially what this handout does is it gives you a summary of all the transformations all in one spot. So it just says, if you take a function and you add a c value out to the side, then that's just shifting you up. If you subtract a c value, that's shifting your graph down. So think about here on this first one, your parent function, I'm saying for all of these, you'll notice they're all x squared. I'm letting our parent function be y equals x squared, which we know is just that parabola, like so. Of course, it does go through 0, 0 there. But then we know that, okay, well, this plus 2 then here shifts that graph up 2 units, and this would be my new graph, and that would be the graph of this piece right there. If I wanted to do f of x minus c, so this parent function here in the black curve there, if I want to do minus 2, then that minus 2 tells me I'm shifting it down 2 units. So see what will happen here. If I shift it down 2 units, then we are looking at that curve. Kind of, it's a pencil. There we go. Okay, so that's the idea here. When you're inside parentheses, I'm gonna speak more about that with the notes itself. So without further ado, let's just go to these notes and jump right in. So looking here on the first page, there are some general patterns associated with your transformations, and so to keep that in mind, anytime you see something that's happening inside the parentheses, you're always going to note that those are horizontal transformations, meaning your left-right movements. And associated with those horizontal transformations, it should be noted that horizontal transformations always move opposite of what you think. Okay, I have it actually, I could just use a highlighter here. Horizontal transformations always seem backward or opposite to what you would think or expect. Okay, so I'll come back up here and just write for you inside parentheses, horizontal, opposite of what you expect. On the other hand, though, if the term is outside the parentheses, and that's a vertical transformation, and that occurs how we would normally expect it to. For example, if it's a plus, we expect it to go up. If it's a minus, we expect it to go down. Okay. Order of operations are performed in reverse order with horizontal transformations. So that's something else to get. I've highlighted that here for you, but they're performed in reverse order with horizontal transformations. It should be noted down here in the box below, addition or subtraction indicates a shift, a left-right movement. Multiplication indicates a stretch or a shrink. And then a negative sign indicates a reflection about an axis. If I go back real quick to this handout, down at the bottom about in terms of the stretch and the shrink, just so that we're clear, you'll notice here in this top one, h of x equals c times x, and they're both of these are c times x, and you get one of them gives you a stretch and one of them gives you a vertical shrink. The difference is, if you notice in the top one here, this is c is greater than 1, meaning it's a positive number. And likewise down here, here your c is also positive. They're just saying the absolute value, but essentially this one represents that we are talking about, let's get a, so we can see it. We're talking about a whole number on this one. And here, if c is between 0 and 1, then we're talking about a fraction. So if that number in front of your function is a whole number, you're going to be stretching it vertically. If that number in front of your function is a fraction, you're going to be shrinking it vertically, okay? And likewise, you'll notice that down here below on the horizontal stretching and shrinking, it is, you know, c down here is a whole number, c here is a fraction, okay? So again, this is whole number, and then this is fraction, okay? So remember, horizontal performs how you think it would. So in this particular cases, you're going to be dividing your x by your c value, and in this case here, you're going to be dividing your x by your c value. Horizontal performs how we think it to be. Vertical, being outside here, we are going to be multiplying on both of these. You're going to be multiplying your y values by c. Multiplying your y values by c, okay? Just so you're kind of aware of that. I think those are the biggest pieces. Those bottom four there are the hardest ones to kind of wrap your brain around at first anyway, okay? All right, so we'll go back to our notes now. All right, so I've got these notes here, and I'm going to, in example 1, look at the function y equals f of x, y equals the absolute value of x. And so as you saw on that previous handout, absolute value function is that nice V-shaped curve. So I'm just going to go ahead and crank that out for us. I mean, if you think about it, if you put an x value of 1, absolute value of 1 is 1. Put an x value of 2, absolute value of 2 is 2, and so on. And we come over here to a negative. Absolute value of negative 3 is positive 3. Okay, so here's our function, y equals absolute value of x. Now, throughout example 1, got multiple pieces here, but throughout example 1, I'm going to apply transformations to it, okay? So here's something that I always kind of keep in my back pocket whenever I'm working through these transformations. Think about, let me get it moved back to where it's supposed to be. That's important. Okay, so think about, as I mentioned up at the top, horizontal transformations are inside parentheses. Vertical transformations are outside. So horizontal inside, vertical outside. Remember, horizontal is opposite of what you think it's going to be. Vertical is like you would think it to be. Horizontal, no, but we'll keep it like that for now, okay? So now for this top one, this plus 2 here is outside the parentheses, okay? So that means it's a vertical transformation. I'm going to be taking my original graph of absolute value of x and shifting it up 2 units. Okay, so what I'm going to do here, just sort of give you a frame of reference. Here's the original graph, and I'm not going to connect the dots, but here's your original graph, y equals absolute value of x. That plus 2 takes all of these purple points here, and it's going to shift it up 2 units. So here for this 1, it goes up 1, 2 units. Go up 1, 2 units. All right, go up 1, 2 units. That'll be as far as I can go. Here, here, and here. Okay. And then this here that I have in red, that would be my final graph. Okay, that would be your f of x. F of x equals the absolute value of x plus 2. Okay. All right, I'll let you try the next one. I encourage you as we work through this set of notes, definitely pause the video so you can and have the solution key handy for yourself so that you can kind of follow along and make sure you're tracking. This is it can be a trickier section. Now you'll notice here, so I'll let you try the next one. Let's move on to the one just behind that. F of x equals the absolute value of x plus 2. So I know it's not a parenthesis here, but think about the fact that that plus 2 in this particular case is inside the absolute value bar. So that means it's inside. So whenever it's inside, that's a horizontal transformation. So remember, horizontal occurs opposite of what we think, because if you think of plus 2, you think, okay, well then I'm going to shift it to the right. But technically here, this absolute value of x plus 2, you are shifting left 2 units. So I'm going to do the same thing I did before. I'm going to draw what our original parent function was, absolute value of x. And now think about, okay, I want to shift all of these points over 2 units to the left. And so I usually start with my vertex over 1, 2 units. And now from there, I can just generate my V-shaped curve, right? Go up 1 over 1 for as much as I can. Okay, and then this would be your new curve. Got a red one there. Okay, that would be our final graph of absolute value of x plus 2. Okay, flip it on over. Absolute value of x minus 2. Pause. Try that one. I'm going to move on over now to the one just beside it. F of x, or y, equals the absolute value of 1/2 x. All right, so you notice this time that the 1/2 is inside the parentheses. So since it's inside, again, we're talking about horizontal. Get my pen going here. Since this is inside, so the factor here is inside. So we're talking about a horizontal transformation. Horizontal, remember, that means you left or right, so you're affecting your x values. You would typically think, oh, well, it's 1/2 times something that you'd be multiplying, but remember, horizontal is opposite of what you think it should be, okay? So that means actually here we're going to take our x values, we're going to be dividing all of our x values by 1/2, okay? So I'm going to, again, draw my basic graph first. And, I will also note here, because this is a 1/2 here in front, that being a fraction, right? Since that's a fraction and it's inside parentheses, then we are doing a horizontal stretch. So this will be a horizontal stretch by 1/2. Okay, so think about it. Your vertex here is not going to change. Let me get back to my red. My vertex is not going to change, and let me let's kind of list out a few points here on this graph. So we've got the point 0, 0. I'm just going to use these first 3 points, and we've got 1, 1, and 2, 2. And let's look at what 1/2 absolute value of x is going to do. We said it should take, you're going to, essentially, it's going to keep all your y values the same. You're just going to be dividing your x values by 1/2. So get this a little bit better here. So all my y values are going to stay the same. So I'm still going to have 0, 1, and 2 there. But I'm going to take each of my x values and divide by 1/2. So 0 divided by anything is still 0. So my vertex is staying the same. Let me get it. And then the next one, you have 1 divided by 1/2. So you could use your calculator. You just would need to put the 1/2 in parentheses, or recognize that this means 1 times reciprocal, 2 over 1. So that's just 2. So my next point would be the point 2, 1. And then the last x value is 2. You're going to be dividing it by 1/2, which is the same as 2 times reciprocal, 2 over 1. That'll give me a new x value of 4. So I have 4, 2. So now hopefully you're getting the idea. Oh, it was a horizontal stretch, and sure enough, let me make these in red so it's a little bit easier to see there. There you go. So horizontal stretch. And so you can imagine then that my -1 is going to do the same thing as the positive 1 did. So I'm going to have -2, 1, and -4, 2, like that. Just a mirror image there. And that's our final graph in red. I'll try to be consistent today and do all my final graphs in red if I can be consistent. All right, so I will let you look at the next one. Again, it's inside, so you should expect it to be horizontal, but this time, because it's a whole number, instead of stretching, it's going to shrink. Okay, and again, you're still going to be dividing your x values by this number here. And I always just recommend making a little table there, especially as you're first getting started. Some people are more visual, and they can take that original graph and go ahead and generate the graph that I have here in red. And if you can, by all means do so. But if you need some points to go by, you're going to see me writing these little tables as we work through this set of notes, okay? All right, so I'm going to move on and work out the next one. F of x equals 1/2 absolute value of x. So it's outside, okay? So since it's outside, then that means it's a vertical. It's a fraction though, so it's going to be a vertical shrink. So it's going to be a vertical shrink. But vertical, remember, affects your y values, and it affects it how we normally would think it would, okay? So since this is 1/2 times, we're going to be multiplying our y values by 1/2, okay? So I'm going to generate our original graph here. Just going to go out a little bit this time. And I'm going to pick those same 3 points again. So we had 0, 0, 1, 1, and 2, 2. And all that needs to happen this time is that we're keeping our x values the same, so 0, 1, and 2. We are now taking our y values and multiplying it by 1/2. So 0 times 1/2, that's still 0. 1 times 1/2, that's 1/2. 2 times 1/2, so half of 2 is 1. All right, so now let's plot these 3 points. This is helping you generate the 1/2 absolute value of x. So now if I plot these points, so I have 0, 0, 1, 1/2, there we go, and then 2, 1. Okay, so then it would also be like -1, 1/2, and -2, 1. Okay, so it kind of just looks like this. It's vertically shrinking it. Okay, you can see from your original purple dots, now your red dot, that's your final graph there. Okay, all right, I'll let you try the next one, another vertical relationship there. Let's look at the next one. You have a negative associated here. Negatives always refer to a reflection. If it's on the outside, as you see here, you reflect over the x-axis. And that's noted on that summary page as well. But if it's outside, then it's reflecting over the x-axis. So here's what's going to happen then. I'm going to draw our original graph for us. Okay, and I'm just going to reflect it over the x-axis. So think about it. Well, the vertex, that's essentially where it's going to hinge at, right? But the point 1, 1 is going to become 1, -1. And 2, 2 is going to be 2, -2. Kind of think about it just sort of hinging there at that vertex point. And now if you take a look at it, you know, if I were to go back in up here and fill in the purple graph, hopefully you would agree, oh yeah, that definitely looks like it's been flipped over the x-axis, because if I were to flip it over the x-axis, those graphs would be on top of one another. Okay, so f of x equals negative absolute value of x. That's this graph here in red. Okay, it just flips you over the x-axis. Flip it over then, top of the next page. When you see that negative on the inside of your function, that is reflecting you across the y-axis. So anytime you're inside with the negative, still references a reflection. It's a reflection over the y-axis. Now with the absolute value function, that's not going to, let me pull it out here real quick, crank it out. Think about it. That's not going to change any, because if you look at the graph in its original state, hopefully you already notice it's already reflective over the y-axis. So if I go through and, you know, 0, 0 is still going to stay where it's at, but 1, 1 is just going to become -1, +1, and -1, +1 is going to become this point. So I'm going to have the exact same graph here as I did with the original f of x, okay? This actually brings up a throwback to what you looked at in the last section about symmetry. If you remember this fact that, let me get my pen a little bit smaller, remember this function or this piece here, that f of -x equals f of x, that when that happened you were even, and if you maybe even recall, all even functions are always symmetric to the y-axis. And so if you think about it here, then, you know, here's your f of x function. F of negative, when you put in this negative x, the absolute value of negative x is the absolute value of x. So we're finding here that when I put in negative x, I get the original function right back. So this is definitely an even function, and it's symmetric to the y-axis, okay? So putting that negative there on the inside and doing a transformation in this particular problem might seem like, well, I didn't really do much, but just so you kind of see that relationship, and hopefully you're kind of recognizing that tie-in. All right, so let's move on over then to the next one. A lot more going on, okay? Because basically at this point now I've added everything in here for you, okay? Try to work from the inside out here. So think about inside here, this +2, because it's inside, that's going to be a horizontal, so that's going to be shifting us left 2 units. I'll try to list it out here what we've got to do. So we're going to shift left 2 units. Then you've got a negative right out here, so I'm going to kind of take it piece by piece. So you've got a negative and it's on the outside. So since it's on the outside, remember, you can see it right here beside you. If it's on the inside, you reflect over the y-axis, but since your negative's on the outside, you're going to reflect over x-axis. Then you've got this 2 on the outside here. So, and this is where I'm talking about doing your order of operations opposite. You know, you typically would like come over here and subtract before you'd multiply. Oh wait a minute, I said that wrong. Never mind. We need to multiply next. I think I know what needs to if it was all inside, that's what we would do backwards. But anyway, we don't have more inside. All right, so sorry about that. So we have this 2 here on the outside, and it's being multiplied. So since it's on the outside, you perform what you normally, how you would think it would happen. So that means here that I'm going to be multiplying my y values, because on the outside that affects your y values. Multiply y values by 2. And then lastly, you've got this -3. Again, it's outside, so that is going to shift down 3 units. So remember, when you're on the outside, it affects what you would expect it to affect, and in the same direction. When it's on the inside, it's the opposite. All right, so there's a lot going on here. So let's get that back. Okay. So I can get. All right, I'm going to draw my original graph. Grab a few points here. I'm not going to connect it unless I have to. Let's start working through this. The first thing I'm going to do is shift this left 2 units. So I'm going to take all of these major points and shift myself left 2 units. So I'm going to do that here in the blue. So I'm going to shift left 2 units. Then I'm going up 1 over 1 from there. Up 1 over 1. Okay, so I'm just going to work with those, 3, 4, 5 points there. Okay, so now at that point, I've taken care of, I've done the left, okay? Now it says I need to reflect over the x-axis. So I'm going to take all of my points now, reflect over the x-axis. So if I'm reflecting over the x-axis, then the vertex here is going to stay the same. I'm going to hinge at that vertex and then bring us down. So then down 1 over 1. Down 1 over 1. Okay, so here's my new graph. All right, so that represents the green. Now it says take all your y values and multiply those by 2. All right, so let's actually write out these ordered pairs that we have here, and probably just work through these over here on the right. So I have the point -2, 0. I have the point -1, -1, and I have the point 0, -2. I mean, I could do all 5 points if I wanted to, but I think these 3 will get you sufficient in the right direction. We are now multiplying our y values by 2. Multiplying y by 2. All right, so that means all my x values are going to stay the same. So I still have my -2, my -1, and my 0. Just multiplying those y values by 2. So 0 times 2, that's still 0. -1 times 2, though, -2. -2 times 2, -4. So now if we plot these new points, I still have the same vertex, but now I have -1, -2, and 0, -4. So then, now think about then this one's going to be here, because it's got to be a perfect V-shaped, right? All right, so then that's there. That's those points. Now from there, take all of these points here, and I'm going to shift each of those down 3 units. So this was there. And I will go to the red. I'm going to shift each of these down 3 units. So I'm going to start with the vertex. I'm going to go down 1, 2, 3. Down 1, 2, 3. That's about all I'm going to be able to show here on the graph. And take this one, go down 1, 2, 3. And that would be our final graph. Okay. Again, do what works for you. If you need to make more tables, by all means do so, because you could come from here and whenever I say that you're going down 2 units, then you could take all your y values and subtract. I'm going down 3 units, excuse me. You could take all your y values now and subtract 3. So 0 minus 3, oh, negative 3. Negative 1 minus 3, oh, that puts me at negative 4. Okay, so you could do that if that would help you as well. All right, so I will let you look at the next one, but I'm not sure if I wrote this on the solution key or not, but I'll write it here. You might want to pause the video first and try it yourself. All right, so what I would say here is that inside the parentheses, that minus 3, shoot, sometimes this does not want to do what I want it to do. Gotta get this back where it was so that's not confusing. Okay. Now, that minus 3 is inside parentheses, and that means you're going to shift it right 3. Do that first. The 1/2 is outside, so that means you're going to be multiplying your y values by 1/2. The plus 2 is on the outside, so that means you're going to shift up 2 units. So remember, when you're outside, it performs how you like it, and then you can check the solution key from there, okay? All right, I'm going to scoot on down here to example 2. It says to describe how each graph can be obtained from its parent function. So I'll look at letter A here with you. In letter A, we have y equals 1/4 square root x minus 3 plus 5. So your parent function here, just so you're aware, the parent function would just be y equals the square root of x. So you're looking at, we're trying to figure out, well, what did they do to that graph right there with all of this, subtracting 3, multiplying 1 by 1/4, and adding 5, okay? Generally, I mean, you don't have to say these in any particular order, okay, in terms of like how you would graph it or anything. So you can just, you can work left or right. Typically, I still, I guess if I were talking you through it in class, I would still say, okay, well, I'm inside here, so this minus 3 is going to shift me, since it's inside, it shifts opposite of what you think, so it's going to shift you right 3 units. Then the 1/4 is on the outside, so that's going to be a vertical shrink, because it's a fraction, by 1/4, or in other words, you're going to be multiplying your y values by 1/4, and then lastly, that plus 5 is going to shift you up 5 units. Okay, so that's what we're looking for there. Okay, I'll let you. I think that the solution key is self-explanatory with those 3. So I'm going to move on over then to the next page. In example 3, it wants us to write an equation from the function that has these characteristics. So I'll do letter A with you. It says, okay, now that we want the shape of y equals x squared, so I want to take the parent function y equals x squared, and I want to apply these transformations to it. I want to shift it left 3 units. So think about that. If I'm shifting it left, then that's inside or outside parentheses? Hopefully you agree that's inside parentheses, and because it's inside parentheses, it's opposite of what you think. So since it's left, you're actually going to be adding 3. I'm going to shift it up 2 units. Okay, so remember, up and down are outside. That's vertical, so that's outside, and it performs as you would expect it to. So that's going to be an up, so plus 2. Then you reflect over the x-axis, and you might need to look back now, but if you reflect over the x-axis, you have to ask yourself, I'm reflecting over the x-axis, is that inside parentheses or outside parentheses? And it's actually outside. Just put your negative there, and nope, I can't forget my squared. Okay, that would be the function that we're looking for there. Okay, all right, I encourage you to pause, try letter B, check yourself by the solution key. We'll move on down to example 4. In example 4, they just say, okay, well, here's a point on the graph, -11, +6. And they want us to find the corresponding point on the graph of y equals g of x, okay? And g of x is identified for us down here in letter A, B, and C. So in letter A, they are putting a -1/2 on the outside. So they're saying -1/2 times the original function. So if you're doing -1/2 on the outside of your function, remember, it performs as you expect it would, so you're going to be multiplying. And since it's on the outside, it's affecting your y value, so you're going to be multiplying your y value by -1/2. So that means you're going to take the point -11, 6, and it's going to be taking that 6 and multiplying it times a -1/2. So it's going to turn us into new ordered pair. X value is going to stay the same, but 6 times -1/2, so you think of this as half of 6 is 3, so positive times a negative, so it would be -3. That's the idea there. Okay. I'll do one more with you. In letter B, g of x equals f of x minus 2. So you're inside parentheses here, so remember that's horizontal, so that's affecting your x values. So, and remember that in this case, when you affect your x values, it's opposite of what you think. So you're going to be taking your x value and adding 2 to it. So think about your normal order pair, your -11, 6. We're going to be taking that -11 and adding 2 to it to give us a new ordered pair of -9, 6. Okay, final answer. All right, I'll let you try C on your own. And we'll do one more here together in example 5. Example 5, I've just given you a graph with I think 5 major points here. You've got the point, I'm going to go ahead and outline them here. You've got the point -2, 2. You've got the point 0, 0, and you could even list the point -1, 1 as well. But I'm just going to go here to the vertex of 0, 0. Then you got another little high point up here, so 1, 1. And then another touchdown at 2, 0. So here's what I would do in the problems below is I would go back to, okay, here are my major points. Now let me perform these operations on it. So in the first one, it wants me to say 2 times these functions and then add 1. So remember, this 2 on the outside performs as you would expect it to. It's going to be multiplying, and since it's on the outside, it's going to be multiplying your y values. So think about, okay, then all my x values are going to stay the same, so -2, 0, 1, 2. Those are all going to stay the same. Let's multiply these y values by 2. So 2 times 2, of course, is 4. 0 times 2, still 0. 1 times 2, 0 times 2, still 0. So now if I come and I plot these points, so I have the point -2, 4, 0, 0, 1, 2, 2, 0. So vertical stretch, right? It's on the outside, vertical stretch. So here's your new graph. Now the last thing I need to consider is that I need to do +1. Now +1 would be shifting all of these major points just up 1 unit. So I'm going to take all these major points and go up 1 unit, up 1 unit, up, up. And again, my final answer here, the red line. That would be the graph of your 2 times g of x plus 1, okay? And then I encourage you to try the next one and then plot that as well. I believe on the solution key, I wasn't able to plot it, but I was able to give you all the ordered pairs. So if you plot the final ordered pairs, you should get, I'm gonna go ahead and here in this video and give you what the final graph would look like. So it should look like here. That's what kind of looks like a lightning bolt. Okay, that's the final graph. for this particular function, okay? Let me know if you have questions. I know this is a little bit of a tougher section. There's a lot to digest. It really comes with practice, so you got to take the time to practice with this material, okay? All right, thanks a lot. Let me know if you need anything. Bye.